Cześć i witam. Hello, welcome everybody to another STEM Racing Poland webinar. Today I'm joined by Reece Lillie from Aston University. And hey Reece, introduce yourself, say what we're going to be doing today.
So hello, thank you for joining us and thank you for the invite, Victor. I'm Reece Lillie, so I'm from Aston University, and today we're going to be talking about how we manufacture STEM racing cars and how Aston University can help you if you don't have your own manufacturing facilities.
That sounds good. I think we'll just get straight into it.
So, as we said, I'm Reece Lillie. So, just a little bit about me. So, my background is as a machinist. I'm now head of the technical services in a university, but most importantly for this, I run Aston University's STEM Racing Centre of Excellence. So, by that, we offer a comprehensive support package, and we also support the competition in various different aspects, both within the UK and globally. So you'll probably see my face around various different areas. So today we're going to be looking at how do we start when we think about the manufacturing process for these cars? Where do we start with the design aspects? Some things that we need to remember as we start designing the cars, especially for the manufacturing stages. And we're going to have a little look at how the cars are made. We've got a couple of short videos to explain what CNC routing is, what 3D printing is for those that might not be aware. And then what do we do once we've got our car manufactured and assembled? And then lastly, for any teams that may be struggling to manufacture their cars or have available machines, how can Aston University help to ensure your cars can be manufactured ready for your event later on in this year? So I think this is an obvious point, but you'll hear me reiterate this multiple times. The starting point for any team, regardless of where you're competing, is the rules and regulations, and making sure that you use both rule sets in combination with each other, because you'll find little nuggets of information in both, and it's making sure that we join those together at the very beginning of this process to make sure that we don't make any mistakes or any oversights that could cost us further down the line. So it's really important to make sure that we're using the right regulation set and that they're of the right date. So make sure that you read these. These will become something you'll know and learn to love and hate at the same time. But they're going to help you make sure that you perform at the best when you come to your competition. So when we talk about a car assembly in F1 in schools, there's a set of regulations that we need to make sure we're adhering to. As you're using a development class set of regulations, we need to make sure that we have a car body that is made from the official F1 model block that is also CNC routed. We need to make sure that we have our halo to ensure that we can safely decelerate the car within the stop zone. We need to use 4 standard wheels, 2 standard axles with 4 bushes, a front and rear wing assembly that is down to your design and development process that you go through. You're allowed a surface finish, including decals and graphics that will be down to you as a team to decide and adhere. And then we need to make sure we've got our logos and a CO2 cartridge chamber. The CO2 cartridge chamber does come standard within the block, and it is at a standard height. So we need to make sure that we are working within those height limits that are put within the technical regs. And then we need some tether line guides. So that was what we class as a car assembly. Anything outside of that then starts to infringe on our technical regulations and scrutineering regulations. And this is where manufacturing and design starts looking at exactly what's involved. A lot of this is available within the downloads on the websites, and we'll go into that a little bit later. So standard components, I've got this in 2 sections. These are all available to download on the website, but most importantly is our no-go zone. And that's a part of the car that you cannot alter and you cannot edit. You can download this, and depending on what offset you want to use, that's all available, and that's a good starting point to make sure that you're rule compliant at the start. We then need to download the halo and the helmet, and this will form the final part of the no-go zone area that you cannot effect through your design. These are all available to download on the STEM Racing website under the Download tab. Alongside these, the other standard components are on the left-hand side, I'm looking at the screen, are the hubs. In the middle, there are the axles, and at the end, there's the standard wheels. Within the rules, you'll be told that the standard wheels has certain dimensions, and that Doug obviously didn't agree with that statement. So the wheels will have the dimensions also specified, because within the rule set, you can make your own wheels as long as they are to the set dimensions of a standard F1 in schools wheel. So whenever we start thinking about the designs, it's always really good to start putting pen to paper, get some rough sketches of what you think your ideal F1 in schools car, sorry, your STEM racing car is going to look like, so that we can start the ideation stage. Once we've got past this, we've then got an opportunity to prove that we've had a design process which needs to be documented within your portfolios. So it's really important that we start documenting everything we're doing at this point of your design journey to make sure that your portfolios look as authentic and are as realistic as possible. So once we've got some ideas and we know what sort of trajectory we want our car design to take, we then need to start thinking of how we're going to fit the no-go zone into it. Now within development class, you can see along the bottom, you can offset your halo. So it's really important to start by deciding where your halo is going to sit within your design. Are you having a shorter car or a longer car? And how will the halo affect this? Because as soon as we have decided on a rough design principle, a design idea, we're then going to need to start transferring this into CAD. To do this, we download our no-go zone, and then we can start loading it into any CAD software of your choice. Once we've done this, what I always say is start with the no-go zone and then build around it. This way you're going to ensure that you're compliant. If you make sure you check your download that you haven't got any parameters wrong or it's not imported incorrectly, but this is a good starting point and benchmark, and it will make sure that you've already hit and nailed on a compliance within the regulations with a no-go zone and a halo position. CAD software, it's up to you what you want to use. All the downloads can come as step files and STLs, so it's all transferable through whatever package you and your school are using. Once we've done the design, what I'd say is to try and test some of these designs, so put them through some sort of CFD software, potentially not FEA because you're not going to have components under stress because you're in development class, but definitely start looking at some of the CFD. ANSYS, Autodesk all have packages that you can use to do this, and you're going to start looking at what the aerodynamic drags and principles are around those cars. And that can help you then analyze your designs to decide which ones you want to take forward into manufacture. So I know I spoke a lot there. So some of the most important things to think about are how are you going to manufacture the car? So they're going to be CNC'd. Are all of your wings going to be 3D printed, or are you going to try and incorporate some into the body so they're foam? This will depend on the complexity of your wings and the forms that they're going to take. Think about how you're going to assemble each component together. It's nothing worse than making it and then not knowing how it's going to go together at the end. Are you going to use glue, magnets, clips? What sort of other extra components are going to go into that to allow this car to go together seamlessly and look the best on the day? Make sure you think about the rules and the regulations that govern each component, and then how they govern each component once they're assembled, because they'll all have individuals, and then as they come together, they'll form part of the car that will then be scrutinized. So we need to make sure that individual parts meet, and then once they're together as a unit, the unit meets regulation compliance. Utilize analysis software like ANSYS to optimize your car designs, and then validate it with the real world testing afterwards if you've got the availability. And then make sure that you're documenting your design and manufacturing journey ready for your portfolio so that you've got everything ready as you go along. So then looking at the car manufacture, The car manufacturer for most development class cars takes on a right and a left program, which is a mirror. So we'll machine the right-hand side, then rotate it by 180 degrees and machine the other side. If you're going to use Aston University services, we normally use a 1/4 inch ball nose cutter as standard unless you ask otherwise within your request. So we can go through that later if you are going to use our services. But this car is being done with a 1/4 inch ball nose, and they take roughly 20 minutes to machine from start to finish. They'll be cut off the block, finished at the front, and then you'll be able to assemble your wings on. Once you've got a car that's been machined, we then think about 3D printing of the other elements. 3D printing forms in layers. We normally print most of our STEM racing cars using PLA with a 0.1 layer height with about a 10 to 20% infill. This proves strong enough for most cars that we produce and gives us a nice finish. These take 3 to 4 hours, and we always use a soluble support, so we've not got any breakaway structures, so that they come out a nice complete finished component. I like the one you can see in the video that's just given an example. After the car's produced, and I also say that you should do this when you're designing it, CAD's great at being able to measure parts. Think about the scrutineering scorecard. It's available, it's within the regulations. Check your components as you go along and just see that everything is meeting your standards, and build in some tolerance. Because we're doing subtractive manufacturing on the car body, we need to make sure that we build in a tolerance, because if we get something that cuts slightly undersized, we don't want to be falling foul. So I'd always build in a tolerance on all components. And the same with 3D printing. Sometimes you get shrinkage, sometimes you get expansion. So make sure that we've got some tolerance to allow parts to fit together and meet the rules and regulations. Don't view the scrutineering card as the minimum that you have to hit. Build in a little bit of a buffer zone, because you don't know on the day. It might be a warm room and things might expand. It might be a really cold room and things could subtract. So environmental changes can make a difference if you've gone right down to the number. All of the scrutineering gauges that are used are available to be downloaded, and you can cut them yourselves. So most of them are laser cut components. You can make them yourselves, or if you are using our services and you wish to add this onto your order, there is something that we could produce for you as well, so that you have the opportunity to check your cars before they go to a competition. So that's a brief whistle-top tour of design and manufacturing the cars. So for anybody that would need some help from Aston University, we offer a wide range of different types of support for teams competing from the UK, and we're happy to extend this support globally to competing teams as required. The support that we've currently been asked to offer to anybody competing within STEM Racing Poland is design support, and then manufacturing, including the supply of materials and machining them to your individual design for a standard fee that will be set across the competition. This will then include all the standard components, CNC machining of the model block, 3D printing of the wings, halo and helmet, and then the supply of all the standard components within a package. If you do want to take us up on this offer, an email will go out at a later date with some deadlines to make sure that this is all achievable with postage and customs, etc. But what we will need is you to email your intention to use our support, so that we can arrange an online review meeting to ensure that whatever designs you're planning to do and are completing are able to be manufactured using the equipment we have. Once your review is done and any changes or adjustments are made, we can have another review if you need one, but then we need you to complete the manufacturer request form and then send this along with all your files for your components to the stemracing@aston.ac.uk email address. And then what will happen is we will confirm your order, we will give you a completion date, and then we will need you to arrange a courier to come and collect your components in a package. We will package it, they will collect the package to go to whatever your location of shipping choice is, and then we will invoice you just for the manufacturer fee. So hopefully that's sort of gave a little bit of an overview and answered some questions that are there, but I am here and free to answer any other questions that you may have or that I haven't covered.
Well, in the meantime, whilst I'll just type in chat if you have any questions, feel free to ask, and that should go to both chats. But in the meantime, I'll just ask for a bit more context. So, how many cars has Aston roughly produced?
So this year alone even, so starting from October, we've done,
not even a full year.
So not a full year yet. We've done around 250 cars for teams within the UK, Ireland, and then some special support cars that have been requested from areas.
So definitely an expert in the matter. Maybe you could consider yourself.
I'd like to think that we're good at what we do now. We've been a centre of excellence officially since 2021. So we've been doing it a number of years, and we've got a good team here that can support most queries that come from teams. There's no query that we won't support as long as it's sensible and within our ability to support it.
What would you say are the most common mistakes you see teams either request from you to do, and you kind of look at something and you know it's already going to go wrong, or you just see other cars because you've been around many competitions, you've been last minute tech support for many teams. So what are some of the most common mistakes you see in the manufacturing and like build of a car?
I think some of the most common problems that we see are not checking their design against the regulations before they send it in. So we see quite a lot of no-go zone failures, canister height failures. Now that we've got the halo in and the halo has a standard height, we've seen a few that have had halo position problems. A lot of these should be dealt with as long as you download the correct no-go zone for your class. But a lot of them are normally around overall size, width, length, height, weight sometimes because they remove too much material. So a lot of the time it's to do with the scrutineering rules and not meeting the size restrictions. One of the other big ones is that we can't actually machine the car from the standard block because they've designed the car outside of the realms of the standard produced F1 block.
And roughly, what is the fee? What is the cost in pounds? And I'll quickly head calc it over to Zloty because it'll be pretty similar.
So any car that we manufacture, you only ever pay for the manufacturer, or the other support comes alongside that. So it's £35 per car produced.
So in Poland, in Zloty, that would be roughly 170 Zloty per car, something in that realm. And plus the teams obviously have to sort their own shipping.
Yeah.
But that's just the price of a starter kit, right? That's a very reasonable
we do the
price.
manufacture and everything just for the standard price of a starter kit from the competition. So we're not here to make profit or anything like that. This is all about supporting the next generation of STEM enthusiasts.
Just out of curiosity now, how many of your cars have you seen at World Finals or have made it to World Finals?
So we've seen a few. We've probably not as many as we've seen at Nationals. So due to the competition and the way it works, a lot of teams that are making World Finals normally have their own kit.
Yeah,
they've committed and they've bought. So we do sometimes do more support for them, but we have seen a couple of cars that we have manufactured attend the World Finals. We were lucky enough to do some show cars a few years ago for a World Finals, and we normally see quite a lot of cars. Obviously, on the regional circuit, there's lots of them, but we are lucky enough to see quite a lot of our cars on national final days on the screens and on the YouTube feed. So it's nice to see where they go. But again, it's all about supporting the next generation of engineers and seeing what they can do and how we can help that journey in any way possible.
Makes sense. And I think a final question from here, a little related, but I know I'm pretty sure you're an expert in this. So sometimes there are sadly last minute breakages for things that happen on the track, things that happen in transport of the cars. And I see that at these events, you're one of the key people that these students will refer to and who take on the job of last minute fixing. And I've seen these cars, even after a breakage, still race, still do well, still absolutely smash it on the track. So
yeah,
God forbid anything happens. What is your advice in these sort of situations?
I think I always say, prepare for the worst. Unfortunately, this is motorsport. Things do go wrong. These cars are traveling at good speeds, and they're also built on the edge of what is technically possible in some cases. So there's nothing that can't be fixed. Things are sent to try us, and it's all about how we overcome those, and that forms part of your story towards the judges as well. Have some spares if possible, but there's always time, and everybody who does do these competitions is there to support you to make sure you get on track and have the best experience you can and the best learning. We've seen cars at the recent World Finals that came off track with wheels missing, bodies in half. It's amazing what glue can do. And these cars are very resilient. They may be made out of a model foam, but that model foam is high density and it will take a lot of abuse before it does completely crumble. But at every event, there's always a car service area, and there's always people who are experienced in how these cars are made and produced who will be on hand to support you to make sure that they will go back together. Or if they won't, there's always a backup plan. But make sure you've got your backup plan as well.
Makes sense. All right. Well, thank you for your time. I think that was a very good overview of how car production should usually look like. And then obviously I'd recommend Aston to any team. Oh, wait, I think I saw a question appear in it might appear in there we go. I'll show it on the stream. Do you expect anything in return apart from money? Are there any other possibilities to do instead of just paying?
So unfortunately, we have to cover our costs of the consumables as part of the running of our Centre of Excellence. So unfortunately, if it is to do with the manufacture of a car, we do need the money for the components used. We will supplement it. So the manufacturer obviously costs us time, power, and things like that. So we do take the brunt of that side, but for the actual consumables, we do ask for the fees to be paid. Apart from that, if you have any other support, we always say if you can put our logo around, it's nice, but we won't stop you getting support if you don't. We understand that sometimes it's not possible, but any support that we give, we do like to have our logo displayed. But if there is a car to be manufactured, we do have to insist on fees because we can't continue to run our process without having the consumables covered.
That's the good answer. I'll leave it for a minute or two as well if people are typing. But yeah, I've definitely seen your logo around on cars at pit displays and on the cars themselves. STEM Racing Poland are now we're gonna try get your logo out there now that you're helping us out like this. We've already got some posts out. It's a nice gesture. It lets
anything that we can do to help, and anything you can do to help us is greatly appreciated. Like I say, we put a lot of time into this to support the students, and we only ever ask you to cover the costs that we incur for the consumables that we cannot get any other way without the funds of that side.
It makes sense.
But like I say, any other support we're happy to do. Calls, design support, anything like that. General questions, email that email address, and we'll be more than happy to respond as soon as we can.
I was just going to say, I've seen the workshop at Aston University specifically with the F1 logo for what it formerly used to be called. I imagine there'll be a STEM racing logo for soon. What roughly what are the limitations? Because you mentioned a few times that obviously you'll do anything that you can do. So you have some pretty common machines, I imagine, and whatnot. But is there anything you've been requesting multiple times before that you just like some teams might expect but you're not able to do? Or what are the limits?
Not really. Most things that the most difficult thing for us to support is software support, because it doesn't necessarily mean we have the software you're using. So we can advise, but a lot of the time, if it's specialist software stuff, we're going to struggle. But if it's about what orientation should I do this, or how could I draw this and design this better, we can normally talk you through on the screen, have a look at what you're doing and get involved. But if it is very specialist, I've got this error code, what do I do? Unfortunately, we can't do that. So that needs to go to whoever your software provider is. We do that sometimes, but unfortunately, we can't help with software errors. Ours is very much about how can we design towards the competition and the specifications and make sure that we get the best car possible on track.
Do I remember correctly that Aston, if a team requests for help and requests a car from Aston, that you guys will send over videos of the car being machined so they can track progress? I've heard about live streams and calls happening before, so they can physically see the cars being produced and machined.
Yeah, if that's something that is of interest, we can't show you the 3D printing because that's 4 hours of. It's the new paint drying.
That's content.
So what we do is we will take some photos of it on the printer when it's printed, and you'll get photos of it on the print bed before it's removed. And we can send you a simulation of it in our slicing software, so you can see how it's going to be built on the plate. When it comes to the machining of the car, we can set a call up. So I'll position a laptop or webcam or something so that you can see me loading your car in, the machining it coming off the machine. So you get that manufacture day experience of seeing your car programmed and machined. We can either do that as a physical call, or we'll do it as a time-lapse video so that you've got some images you can grab and put into portfolios and use that as part of your learning within the design and manufacture stage of your competition. So that is an opportunity. We just need to be told in advance when you submit them if you'd like it to be done on a call, and we'll try and do it within times that suit you. Obviously, this has to fit in around our other commitments. So if we can't fit it for a live session, we will record it and make sure we send that to you via a Dropbox or something so you can access those videos.
All right, perfect. I think we'll slowly wrap this up. We've given people a few minutes to ask questions. I'll just put on the screen again could you skip over to the tab with your email so the people know where what they have to do? I'll send out an email and maybe a post with that email address on it anyways. But if people want Aston services, basically the key part here is first of all, email your intention that you would like their services, so they know that you're interested and know that they can continue conversations. And then from there, it's just a dialogue, I imagine, of they request certain things, you give responses, and eventually you'll end up with a car.
Yep, we'll keep them in the loop the whole way around, and it will be a two-way conversation all the way through until your car is collected by whatever courier you decide. All
right, perfect. Well, thank you, Reece, for coming on. Thank you
Thank you for the invite.
Your support is STEM Racing Poland and STEM Racing as a whole. Again, I see you at all the events. I'm sure I'll see you at World Finals.
Hopefully. I hope you're there. It'll be nice to see you again.
Yeah, thank you for hopping on. This video will stay up on YouTube, so if anybody ever wants to refer back to this for the advice or to find the email address or anything specific, it's just on our YouTube channel. And thank you, everybody, for watching.
No problem.